We're just going to do a little more practice rewriting equations into slope-intercept form. Just because it's really important, because the slope-intercept form for us is the easiest way to work with our equations, because it immediately tells us the y-intercept, it immediately tells us the slope, and so we immediately get a picture in our minds of what that line should look like, and that's why it's so helpful. So again, slope-intercept form is always y equals mx plus b, where the m is your slope, the b is the y-intercept, and so we just want to rewrite equations like that. And right here, we'll see why, right? So again, this first equation, I see 4, and immediately I know that the y-intercept is 4, crosses the y-axis at 4. I see 1/2, and I know the slope is 1/2. I know I'm going up 1 over 2. So if I pick any point, I can go up 1 over 2 and get to another point. And sure enough, it works out. Okay, but if I look at this second example, we can see why. So the first thing I want to do is just make sure it's in slope-intercept form. So I need it to look like this. I need it to look like y equals mx plus b. But it's not y, it's 2y. So I'm going to divide everything by 2 to get just y. So divide by 2, and I get just y equals. Now x over 2, right? I can imagine, I'll just change the color right here. I can imagine that's 1x. So that would be 1/2 x if I divide it by 2. Now 8 divided by 2 is just 4, so plus 4. Okay, so now notice, this line is exactly the same as that line, and so its graph is going to be the same. But if I had just looked at this 8, that is not the y-intercept. And if I had looked at just the 1, that is not the slope. So that's why it's really important to look at it in y-intercept in slope-intercept form, and why in these forms, like right here, for instance, I can't just look at the number by itself, the 8, and think that's the y-intercept. And I can't just look at the coefficient of x and think that's the slope. So let's look at this last one. So the first thing is, not only do I have 2y, but I also have other stuff on the same side, right? And it has to be just y. Just y equals mx plus b. So the first thing I'm going to do is I'm going to get the x term or anything else that's not the y term out of that side. So I'm going to add x to get rid of that. So I'm going to have 2y equals x plus 8. So that's good. But now we have to do the same thing we did before and divide by 2 to get just y. And we end up with y equals 1/2 x plus 4, which is, if you notice, is exactly the same equation as that, which was exactly the same equation as our original. So all three of these are the exact same equation. But only one of them, the first one, immediately told us our y-intercept and our slope. And that's why it's so helpful, and that's why we want to practice rewriting other forms into slope-intercept form. So again, we just got to get it to look like this. Y equals mx plus b. Now, I'm going to give you a tip. If the y is negative, if the y term is negative, as it is here, then my first step I'm going to do is I'm actually going to add y to the other side, because it has to be positive. Notice this doesn't say negative y, it says y. So I'm just going to add the y to both sides. And so I'll have 2x equals y minus 2. And now I need just y, right? So I'll add the 2 to get rid of the 2, plus 2. And I have y over here equals 2x plus 2. And that looks like my slope-intercept form, so that's good. Notice we normally write the y on the left side, and that's fine, because 2x plus 2 and y are identical. That's what equals mean. So I can put either one on the left, on the right, it doesn't matter. That's the same as y equals 2x plus 2. And that is in y equals mx plus b, where 2 is the slope, and 2 is also the y-intercept. Okay, this one over here. Remember, on this first example, the y term is negative, so we added y to both sides. But in this case, the y term is already positive. So I'm just going to leave it where it is, and I'm going to get rid of the x term. So I'll just say minus 2x on both sides. And so we get y equals negative 2x plus 3. Notice I could have also written 3 minus 2x, but I want mx first and b second. So we are done. Y equals negative 2x, so the slope is negative 2 plus 3, and so the y-intercept would cross the y-axis at 3. Okay, 2 more. Again, since the y term here is negative, I'm going to add the y term to both sides. So I'll get 3x equals 2y minus 2. And I want just the y term, so I'm going to add 2 to get rid of that. And I'll get 3x plus 2 equals 2y. And then finally, I need just y, so I will divide by 2. And I got to do both sides, so I get y equals 3 halves, can't reduce, I'll just leave that, 3 halves x, and then 2 over 2 is 1. So y equals 3 halves x plus 1, and if I wanted to write it in that order, no problem. Last example. So the y term is positive, so I'm going to leave it. I'll subtract the 3x. So 4y equals 0 minus 3x. It's just negative 3x, right? Negative 3x. So I don't have to write the 0 plus 0 if I want. And notice, if you notice, you should already see what's happening, right? There's nothing here. There's no b term. So the y-intercept is going to be 0. But we'll talk about that in 1 second. I still need to get just y, so I'll divide by 4. So y equals 3 over 4, can't simplify, so we'll just leave it as negative 3 over 4x. And again, there's no plus or minus something, right? B is just 0. I could imagine if I wanted there being a plus 0 here, right? And that's the y-intercept. But we generally don't write that. We just leave it blank, and so you know the y-intercept is 0. And the slope is negative 3/4. So if I imagine this line, it's going through the origin because the y-intercept is 0, right? And I'm going up 3 over 4, and as I go up, I'm going to the left because the slope is negative. So I go 1, 2, 3, 1, 2, 3, 4. That would be my next point, and I could just visualize what that line should look like.